You know that feeling you get sometimes? You meet someone, and, well, you just instantly think they seem older, or maybe younger than you'd expect.
Yeah.
It's like their face is kind of telling a different story about their age, a story that's maybe more than just years lived.
That's a really common observation, actually. And it taps into something doctors have known for ages. A patient's appearance, their sort of general look, can offer real clues about their health.
Right.
And now there's this really fascinating AI tool trying to quantify that, make it more objective. It's called FaceAge.
FaceAge. Okay, and that's our deep dive for today, right?
Exactly. We're looking at research from Mass General Brigham, plus a video they put out.
Okay.
This FaceAge tool, it uses AI analyzing facial photos to estimate what we call biological age.
Which isn't always the same as your, calendar age.
Precisely. It's more about how old your body seems to be functioning. And here's the kicker. The early results suggest it might even help predict cancer outcomes.
Wow, okay. So our mission today is to unpack that. How does FaceAge actually work? What are these initial findings telling us, especially about cancer?
Yeah, and ultimately, why should you care? Why could this be, genuinely important for health down the line?
All right, let's start with the basics then. Biological age versus chronological age. We hear those terms thrown around, but what's the real difference? Why does it matter?
Well, chronological age, that's simple enough. It's just the number of candles on your cake, right? Years since birth.
Straightforward.
But biological age, that's trying to capture something more complex. It's like the sum total of wear and tear on your body. Your genes play a part, sure, but also your lifestyle, your environment. Everything accumulates.
So two people could be 50 chronologically.
Exactly. But one might have had a really tough life, maybe smoked, didn't eat well, lots of stress. They might biologically seem much older.
While the other 50-year-old who, I don't know, ran marathons and ate salads
might seem biologically younger. And often you can kind of see that difference in their faces, even subtly.
And that's where FaceAge comes in, trying to put a number on that feeling, that wear and tear look.
Precisely. Doctors make these intuitive calls all the time, assessing a patient's vitality by looking at them. FaceAge aims to make that less subjective, more data-driven.
Okay, so how does the AI do that? What's happening when it analyzes a photo and comes up with this biological age number?
So it's based on deep learning, which is basically a very sophisticated type of pattern recognition.
Okay.
It was trained on a huge data set, almost 59,000 photos of people who were presumed healthy.
59,000, that's a lot of faces.
It really is. And by analyzing all those images, the AI learned to connect really subtle facial features, not just wrinkles, but skin texture, face shape, shadows, all sorts of tiny details with different ages in that healthy group.
So it's seeing things maybe the human eye wouldn't consciously register.
Very likely, yeah. It's picking up on these incredibly fine-grained visual markers that correlate with age across that big population.
Okay, so it learns what healthy aging looks like from nearly 60,000 photos. Then what? How did they test if it could tell us anything about people who were sick? Specifically, the cancer patients you mentioned.
Right, that's the crucial next step in the research. After training, they tested it on a completely different group, over 6,000 patients who had just been diagnosed with cancer and were about to start radiotherapy.
And they used photos taken right at the start of treatment.
Yes, exactly. Photos taken at diagnosis, basically, to see if FaceAge could spot any differences or patterns linked to their illness.
And did the AI see something different in the faces of the cancer patients compared to the healthy training group?
It did, yes. And this is pretty striking. On average, the AI estimated the cancer patient's biological age to be significantly higher than their actual chronological age.
Higher? By how much?
About 5 years older, on average, according to FaceAge.
5 years? Just based on a photo? Wow.
It's a noticeable difference, right? It raises this question, could cancer itself accelerate some visible signs of aging? Maybe reflecting some kind of systemic stress.
That's fascinating. But was it just a general they look older observation, or did this FaceAge prediction connect to anything more specific, like how the patients actually did?
Now here's where it gets really compelling. The researchers found a clear link, a correlation between the FaceAge prediction and the patient's overall survival.
Meaning
patients whose FaceAge was higher, the ones the AI saw as biologically older, tended to have worse survival outcomes. And this held true across different types of cancer.
So it wasn't just looking older. That older appearance, as judged by the AI, seemed genuinely linked to the seriousness or progression of their disease.
It seems that way. Like FaceAge might be tapping into something fundamental about the body's resilience or maybe its decline when facing cancer. something beyond what we normally measure.
And you mentioned this was particularly strong for certain patients.
Yes, especially for individuals the AI flagged as looking older than 85 biologically. Even when the researchers accounted for their real age, sex, and cancer type, that high face age still correlated with poorer survival.
So it's adding extra information, potentially quite critical information.
That's the implication, yes. Biological age, estimated this way, might give us another layer of prognostic insight.
Incredible. And there was a specific patient story that highlighted this, right? Someone named Jay.
Yes, the video mentions Jay. He was in his late 80s chronologically. His case really brings the potential here to life.
Okay, what was his situation?
Well, despite being in his late 80s, apparently he looked much younger, was very active, but he had cancer, and his doctors faced a tough call. Go for aggressive treatment, which is risky in older folks, or a less intense approach.
A common dilemma in oncology, I imagine.
Very much so. And this is where FaceAge played a role. They calculated his face age from a photo taken at diagnosis and came back more than 10 years younger than his actual age.
10 years younger, biologically.
According to the algorithm, yes. So this objective data point kind of backed up the doctor's gut feeling that Jay was more robust than his birth certificate suggested.
And that influenced his treatment.
It helps support the decision to go ahead with the more aggressive treatment plan for him.
Wow. So it's not just theoretical. It actually informed a clinical decision in that case. That's powerful.
It really is. And it highlights how this could potentially work in practice.
The research didn't just look at the AI, though. They also compared it to how well doctors could predict outcomes, didn't they?
Yes, they did. And this part was really telling. They asked clinicians and researchers, experienced people, to look at patient photos and predict short-term survival for those getting palliative radiotherapy.
Okay, just based on the pictures.
Just the photos.
Yeah.
Initially, though they were given basic info like age and cancer type 2, and the result, their predictions were only slightly better than pure chance. Just guessing.
Seriously. Even with their experience. That's surprising.
It really shows how hard it is to objectively quantify those visual health cues, even for experts. We all have biases, or maybe we focus on different things.
So the human eye, even a trained one, struggled with that specific task.
It did. But here's the crucial bit. When those same clinicians were then also given the FaceAge score for each patient,
Let me guess, their predictions got better.
significantly better. Their accuracy improved noticeably when they had that objective AI assessment alongside their own judgment.
Okay, that's a really important point. It suggests FaceAge isn't about replacing doctors.
Not at all. It's positioned as a potential tool for doctors, an extra piece of objective data to help them refine their assessments, their clinical intuition.
Like another vital sign, almost.
Kind of, yeah. Or another lab test result, perhaps. Something objective to add to the mix.
And the potential implications here feel, well, pretty huge. If this works for cancer, could it apply elsewhere?
That's the hope. Could it provide similar objective insights for managing other chronic diseases? Heart disease, diabetes, neurodegenerative conditions. The possibilities are broad.
The idea that just a selfie, something so commonplace now, could hold important clues about your underlying health. That's quite something.
It really is. It opens the door to thinking about more personalized health care, tailoring treatments based not just on your chronological age, but on this measure of biological age.
Could you see this becoming part of, like, a routine checkup? Snap a photo for the FaceAge analysis along with your blood pressure.
It's definitely in the realm of possibility down the road.
Yeah.
Imagine tracking your biological age over time. Maybe it could help identify risks earlier or show if lifestyle changes are actually biologically making you younger.
That idea of tracking your aging trajectory, that's interesting.
The researchers are optimistic it could help pinpoint opportunities to intervene, guide people towards healthier lives, potentially extend lifespan.
And you mentioned it might even predict risk for other diseases or general health status, maybe even lifespan itself.
That's the broader vision, yes. Could FaceAge act as an early warning system? If someone's biological age starts accelerating unexpectedly, maybe that warrants a closer look for underlying issues.
Okay, this sounds incredibly promising, but we need to manage expectations too, right? This isn't in clinics tomorrow.
Absolutely not. The researchers themselves are very clear. This is early-stage research. Promising, yes, but much more validation is needed before it's ready for real-world clinical use.
So what's next for the research team?
They're expanding the work. testing it in different hospitals with more diverse groups of patients. They're looking at different stages of cancer, not just at diagnosis.
And tracking people over time.
Yes, tracking how face age changes for individuals over time is crucial. And interestingly, they also want to test its accuracy against things like cosmetic surgery or interventions to make sure it's really reflecting biology, not just superficial changes.
That makes sense. And of course, with any AI like this, especially in healthcare, there are ethical considerations.
Huge ones. Data privacy, potential biases in the algorithms, how the information is used. A strong regulatory and ethical framework is absolutely essential before anything like this gets rolled out widely.
Good point. Who are the main researchers behind this work?
The co-senior authors mentioned are Dr. Hugo Artz, who directs the AI in Medicine program at Mass General Brigham, and Dr. Ray Mack, who's also faculty in that program.
A collaboration between AI expertise and clinical application.
Exactly. And it's worth noting Mass General Brigham has filed provisional patents related to this tech.
Which suggests they see real potential here.
It certainly does. And the work has received funding from major bodies like the NIH and the European Research Council, which adds weight to its scientific significance.
Okay, so wrapping up our deep dive today, if there's one key takeaway for listeners about FaceAge, what should it be?
I think the core message is that AI is showing it can analyze something as simple as a facial photo to estimate biological age, and importantly, that estimate seems to have real predictive power, particularly shown so far in cancer outcomes.
It implies that how we look, maybe more than we realized, reflects deeper biological truths about our health.
Precisely. It suggests our faces might hold objective clues about our body's resilience and potentially our longevity.
It really gets you thinking, doesn't it? How might technologies like this change how we even perceive age? Our whole understanding of aging could shift.
It could. And what other applications might emerge?
Yeah.
We focused on cancer, but maybe it helps personalize fitness plans or nutrition advice based on your biological age trajectory.
Or even just raising awareness.
Yeah.
Seeing your biological age might motivate positive lifestyle changes in a way that just knowing your birthday doesn't.
That's a definite possibility. There's a lot to unpack still, ethically and scientifically, but the potential for earlier detection, more personalized prevention, and just a deeper grasp on aging itself. It's a fascinating space to watch.